Audio solutions for low-frequency device applications. System overview. In low-frequency therapy device applications, low-frequency signals such as 2 Hz to 50 Hz are widely used. The low-frequency signal will be amplified by an amplifier, and the coil will generate an electromagnetic field when it is fed AC current. The higher the AC current is, the higher the level of intensity the electromagnetic field will have. In order to reach this purpose, the amplifier needs to handle high current greater than 12 amps, low frequency such as 2 Hz to 50 Hz, inductive load in the coil, and extremely low load as 1 ohm. Who are we? Shure Electronics is a professional audio solutions provider that provides business partners with the middleware, which can help reduce the customer's development difficulties and save their precious time to market by making the products directly released to the market. Disclaimer. 1. Shure Electronics hereby declares that we only provide related components like amplifier and power supply for pulsed electromagnetic field therapy devices. We have not, do not, and will never cover the final products. 2. Please contact us at store@shure-electronics.com to get the version especially optimized for pulse electromagnetic field therapy. There is a big difference between the standard products and the specialized version in low frequency performance and protection. Product overview. High current amplifier. In order to meet these special requirements for low frequency therapy device applications of power amplifier, Shure Electronics provides wide frequency range amplifier optimized for pulse electromagnetic field therapy devices, which can continuously output 30 amps, featuring flexible load characteristics, wide load range, complete protection, and high reliability. TDBA Series. How WONDOM TDBA Series meet the needs of low-frequency therapy device. Next, we will describe in detail the performance requirements of low-frequency therapy device and whether our amplifier meets these requirements. First, continuous high output current. When the coil is fed AC current, it will generate a magnetic field, the intensity of which is proportional to the current magnitude. The signal generator can only output low current that is too low to generate a strong magnetic field. Thus, an amplifier is required to amplify the current of signal to more than 12 amps. When playing music, the voltage of signal changes. The peak voltage appears occasionally, so there is no need for the amplifier to continuously output high current. But the amplifier needs to output high current uninterruptedly in low-frequency therapy device applications, which is another challenge for the amplifier. With 10 years' experience in highly demanding operations, Shure Electronics is capable of providing amplifiers meeting the requirements of continuous high output current. TDBA Series, which can output up to 30 amps uninterruptedly, and the peak output current can reach 35 amps. Second, good performance of amplifier in low frequency. The impedance of capacitors employed in Class D amplifiers change with the frequency, making the frequency response perform badly at low and high frequency. Namely, the application factor will decrease, so the amplifier cannot output high current. In low and high frequency, gain reduces, so VO-VI reduces and output current reduces. Many amplifiers may not or won't be able to deliver required output current in low or high frequency range. With special technology employed in design, the TDBA series can perform well in low frequency, guaranteeing the amplification factor and the high current output. As you can see from this test image, the frequency response of TDBA series in 3 Hz to 1 kHz is good. If you want a wider bandwidth of low frequency, please contact us. Third, flexible load characteristic. The coil can be seen as an inductive load in essence, and the impedance can be calculated from equation 1. When driving an inductive load, there will be reactive power, equation 2, which will be dissipated inside the amplifier rather than on the load, in which condition the output voltage and current will attenuate. It needs the amplifier to handle the reactive power well, otherwise it will be burned. TDBA series featuring flexible load characteristic that can drive inductive load without bad impact in output. Inductive resistance is proportional to frequency, so it is extremely low in low frequency. For example, the L is 15 MHz, the F is 10 Hz. We can figure out the Z is only 0.942 ohm, less than 1 ohm. According to equation 3, the lower the impedance is, the higher the current will be. So the amplifier must have the ability to endure high current. Fourth, protection system. Stability and reliability is a paramount factor when it comes to therapy device applications. A full protection circuit is employed in TDBA series, covering from input to output to ensure that the system can operate stably at any time. Based on 10 years research experience of Class D, Sure Electronics has achieved related patented technology. The coil will become hot as time passes by. Once the heat is too much, the coil will be burned or it will possibly cause injury to the user. So can we adjust the temperature automatically? Sure Electronics has applied for a patent on the solution to this problem. We will use a patented device to simulate the temperature rise of coil. Then the temperature will be monitored. When the temperature of the coil is over the threshold, T1, the gain of the amplifier will decrease to a lower level. If the temperature still goes up, T2, the gain will decrease again until it is back to normal, ensuring the long, reliable running of the whole system. As mentioned before, there will be reactive power when the amplifier is driving the coil, which will go backwards and forwards between amplifier and coil. Meanwhile, the amplifier is still supplied with power, resulting in the voltage going up, which may cause damage to the amplifier. Enhanced overvoltage protection with a more accurate circuit is employed in the TDBA series to avoid this undesired damage. When the voltage exceeds the set threshold, the amplifier will enter into shutdown mode. Fifth, high stability and reliability. Sure Electronics has built a full set of quality and stability tests into the design and production procedures in the past 10 years. HALT and HASS is properly implemented to uncover problems associated with product design and production and identify potential causes of failure. All test reports are available. HALT is conducted by putting different stress on the TDBA series, including temperature rising and dropping within -20, -150 centigrade, rapid temperature change as 5 degrees centigrade per minute within 40 to -150 centigrade, not working, and +55 degrees centigrade continuous operation. HASS is completely implemented in the production stage to ensure all the improvement measures found in HALT are executed, so there will be no more new defects caused by changes of manufacturing techniques and components.